Okay, let's now begin this next part of our empirical formula lesson. So we are looking at the sheet CC9A.2. It says, first of all, let's calculate the relative formula mass of the following compounds. Okay, so KBr. Well, first of all, K is, let's have a look, 1A. K is 39 plus Br, which is 80, straight off the periodic table. Now, that makes 39 plus 80, which is 119. There we go. Now, B and C I did earlier, okay, on the previous page, so I'm not gonna cover those again. 1D is magnesium nitrate, so that's magnesium 24 plus, now we've got 2 of everything in those brackets there, so that is 2 times 14, which is 28, and we've actually got 6 times 16 because there's 2 3s, and that makes 96. So we've got 24 plus 28 plus 96. And that makes 148. Now finally 1E, aluminium sulfate. So we've got 27 times 2, which is 54. We've got S times 3, because there's SO4 times 3, so we've got 3 times 32, which is 96. And then we've got 4 times 3, 12 oxygens, so 12 times 16, which is 192. Okay, so we're going to add 96 and 54 to that to give us our MR there of 342. Right, let's go over these. Write the empirical formula of H2O2. Well, the simplest whole number ratio of that is simply HO. Divide them both by 2. What about C4H8? Well, the simplest whole number ratio of those, divide them both by 4, leaving you with CH2. C5H12. There's nothing we can divide those by, or divide both of those by, to make a simple whole number ratio. So there we go. D is C4H8O2. Now we can divide those by 2 to give us C2H4O. And finally C6H12O6. The biologist amongst you will recognize this as glucose. We divide this by 6 to make CH2O. There we go. A little bit of simplifying empirical formula there. That is the easy way to deal with empirical formula. Now, we now have a slightly more challenging problem of working out empirical formula from masses. Let's get stuck into this. So, first of all, we have a bit of sodium. In fact, we have 4.6 grams of this, and we have some chlorine, and we have 7.1 grams of this. Now, first thing we need to do is divide these by the AR from the periodic table. Okay, we tap these into the calculator. 4.6 divided by 23 is 0.2. And 7.1 divided by 35.5 is also 0.2. Now to find the simplest whole number ratio, we divide them both by 0.2. And this gives us a 1:1 ratio. So the empirical formula here, very simply, is NaCl. It is important to write that formula. After doing all this work, it is important to write the formula. Okay, let's hit up some 3B now. So we've got zinc, and we've got 10.40 grams of that. And we've got some chlorine, and we've got 11.36 grams of that. So let's go ahead again and divide these by the AR of those. I'm looking, the zinc is 65. So 10.40 divided by 65 is 0.16. Make sure my point's nice and clear. And 11.36 divided by 35.5 is 0.32. So we divide both of those by 0.16 to get the simplest whole number ratio. Okay. Divided by 0.16. Should probably be able to do that on my calculator, but I thought I'd use my calculator anyway. So we have a ratio here of 1 to 2, or ZnCl2. Lovely. Our last one I'll do down here, 3C. We have copper, 19.05 grams of that. We have sulfur, 9.06 grams of that. And we have oxygen, 19.20 grams of that. Let's go right ahead and divide those by the AR, or mass number. So 19.05 divided by 63.5 is 0.3. 9.06 divided by 32 is... Hang on, I've written that wrong, haven't I? I did this last time I did it. That's actually 9.60. I wondered why it came out with 0.283125. It should be 0.3. Let me just check that. 9.60 divided by 32 is 0.3. And finally, 19.20 divided by 16 is 1.2. I'm going to divide those by 0.3 because that's the smallest of the three numbers. That gives me a ratio of 1 to 1 to 4. So our empirical formula here is CuSO4. Job done. Nice. Now we have some other questions to do. What I will do in the interest of having some room is I will simply whiz across here and we will write on this side. So we now have, try right over here, question 4. We need to work out the empirical formula of ethane, or the molecular formula, sorry, of ethane with the empirical formula CH3 and MR of 30. Now, if we have CH3, okay, that equals 15. Okay, now our MR is actually 30. Now we can see that if we times that by 2, we will get 30. So we need to times everything in CH by 2. So the molecular formula there is just C2H6. Fantastic. Right, next let's go with B. I'll do it by here. This one's so straightforward. So ethanol with the empirical formula C2H6O and MR. So if we do C2H6O, what we've got essentially is 24 plus 6 plus 16, which actually equals 46. Okay, so that's the empirical formula. It's also the molecular formula. Okay, it's also the molecular formula. Make sure you stress that somewhere, just so they know what you're talking about. Nice. Right, next, last but not least, we have C. Now C is ethanoic acid, the empirical formula CH2O. Now that is 12 plus 2 plus 16. Okay, now 12 plus 2 plus 16 is 30. Okay, that equals 30. Now our MR here is 60. So again, that's times 2. So to work out our molecular formula, it's just 2 times everything, C2H4O. Fantastic. So that's 4 nailed. Now next, we need to work out both the empirical and the molecular formula. I'm going to write over this way a bit because my fingers are doing really weird things here. So 5. First of all, the empirical formula. So we have carbon, Now we have hydrogen, we have 8.57 and we have 1.43. Now we're going to divide that by 1 and we're going to divide that by 12. Now that makes 1.43 obviously, and 8.57 divided by 12 is 0.71. So we're going to divide both of those by 0.71. That gives us a 1 to 2 ratio, so it's CH2. Now the relative formula mass is 70. Okay, so this is the empirical formula here. Now the relative formula mass is 70, so let's work out. So if it's C5, that would be 5 times 12. Now that I could look on my calculator for that, but that's 60, isn't it? So if I have C5, I can have H10. Now that makes 70, but does it work? Now we have two general formulas here. We have CnH2n plus 2, and we have CnH2n. Now this one is for an alkane, and this one is for an alkene. Okay, now does this fit either of those? It does, doesn't it? Because C5H10 equals the CnH2n, okay? It's just the number of H's is double the number of C's. So this here is our molecular formula. It is that, and it is an alkene with 5 carbons. Brilliant. Finally, 14.8 of a compound contains 2.8 grams of lithium, 2.4 grams of carbon, and some oxygen. Now, how on earth are you supposed to work out the oxygen? Well, you know the total mass, it's 14.8. So if you take away 2.8 and you take away 2.4, you get 9.6, which is the remaining mass, because these three added together make 14.8. Now let's go ahead and divide these by their AR. That one's 16. So 2.8 divided, hang on, that's times 2.8 divided by 7 is 0.4. 2.4 divided by 12, let's stick in the old calculator, that's 0.2. And finally 9.6 divided by 16 is 0.6. Now I need to divide all of those by the smallest, which is 0.2. So I'm going to divide all these by 0.2, divided by 0.2. Now that means we've got a ratio of 2, so 1, 2, 3, which means our empirical formula there, it asks us to do that. We've written the ratio. It is very simply Li2CO3, which is also the molecular formula, interestingly. Anyway, thank you very much for watching.